Hello. In this video, we will take a look at the new Global Illumination system in LightWave 2020. What I'm going to do first is show you one of the end results I'm going to explain how to get to in this video. So what I'm going to do is I'm going to activate VPR, and you can see the nice new clean Global Illumination solution that I have baked for the scene, and because it is baked, I can freely traverse the scene without having to spend a lot of time rendering the Global Illumination solution. I've baked this solution using the new grid baking solution that is an automated full scene baking solution, and I will explain that later. But first, I will go over the new Global Illumination options. So what we have in LightWave 2020 is a two-tier Global Illumination system. We've got a primary Global Illumination plugin and a secondary Global Illumination plugin. These work together in a way that the secondary GI is going to be processed before the primary GI, and the primary GI sees the result of the secondary GI when the primary GI ray hits a surface. And that way we can achieve a much smoother result with much less splotching than before. So let me turn off the cache I had previously baked and show you how the system works without a cache. So what I'm going to do is just use the primary cache and render a frame. While it's pre-processing, you can see that it looks blotchy and uneven, but after the pre-processing pass is done, you will get a much smoother result. Now, to even things out even more, I could activate the secondary GI, which would be pre-processed before the primary GI, and then when the primary GI is being pre-processed, it will actually see the secondary GI that has been processed previously, and the result of the secondary GI is already smooth. So the primary GI is going to use that smooth result. Let me turn on these options. I'm going to explain these options later. So now we see this is the secondary GI being processed. And after it is done, it is going to launch the primary pass, and you can see things smoothing out already, especially here in this wall. And now we have a nice, pretty smooth GI result with 512 rays. Now, what I could do is, if we want to see how these two tiers of global illumination interact with each other, I can actually turn this primary one to brute force. And now the secondary is going to be pre-processed, but for the actual rendering, the, the brute force is going to see the irradiance cache. So let's see what that looks like. You can see the result is a little bit smoother than what it would be with just brute force. Let's try that. So if we switch between these two renders, you can see that because the brute force sees the irradiance cache, the result is much smoother, and it also includes a an extra bounce, like so. So that is how the two-tier system works. Now I'm going to explain the options we have. So we start with the rays, that is as we had before, and the interpolation accuracy is how accurate the interpolation of the irradiance cache is. And let me demonstrate that by setting it to 100. This is the most accurate result, as the name of the attribute says, but it's also going to be the most blotchy. So if accuracy is what you are looking for, then you should use 100% accuracy. But it will create more blotches, so you will have to increase your ray count. But if we lower this to the lowest value we can get, you'll see that the result is smooth, but it will also lose the nice details, especially in the corner areas, because the softening radius for the irradiance cache is going to be as wide as it can be. With the lowest setting, we even lost the shadow computations under these spheres. So I wouldn't recommend using the lowest number setting. Instead, the default 25 should be quite enough to get rid of the blotchiness and still preserve most of the detail. Now we can see that we still retain the shadows, and we have some softening of the corner samples here. You can see that it's not as accurate as it is with the 100% accuracy. You can see that it softens out in the corners, but it gets rid of all these blotches for much faster rendering. It all depends if you want accuracy or faster rendering with less blotches. Now the pixel spacings, minimum pixel spacing and maximum pixel spacing, these are the same ones as before. The smallest irradiance cache sample is 2 pixels, so about, it's a 2 by 2 pixel size, and that is dependent on the projected size of the pixel through the camera. So the samples are bigger here in the far away corners, and this is a good mode to use when you have not baked the entire scene into a grid. If I turn this mode off, it turns into a world space setting, and now we can set the minimum size in world space, so the smallest samples far away are still just 1 centimeter. This will of course render slower from the camera point of view, but it will have a use for when we go into the cache and especially the grid cache settings. The distance tolerance setting is for like these corners or some stairs. If the system, the pre-process pass, takes a sample, let's say here, and the distance tolerance is something high, let's set it to 50 and render this. You will see that it starts to error out, it will leak, and that is because the distance tolerance setting is so high that when the sample was generated here, it actually used the sample previously generated here, because the distance between these samples is smaller than the distance tolerance. So I like to keep it at the default 5 centimeters. It depends what is the scale of your scene or how close you are to a surface. The angular tolerance is the same as before. Now these are new options. The specular, glossy, and subsurface scattering. These are to determine if the pre-process rays should actually use the specularity or the soft reflection or the subsurface scattering when it pre-processes an object. So if I select this sphere object, I'm going to turn off the bump mapping on it and set it to metallic and do a quick render. Since we don't have the specular option on or the glossy option on, you can see that the spheres render black in the pre-process, and they don't so I don't have glossy reflections on. Let's do that again. So you can see that they're black and they will not cast any reflection rays because we've told them not to. But that also means areas that the TI pre-process didn't see, like here, are black because there's no cache to be, from the wall the sphere is reflecting, which is this black back wall here. So what we can do is we can turn these two options on. The use specular means it's a pure mirror without any roughness, so not a soft reflection. And the use glossy means that if the surface does have roughness, it is a glossy reflection. So when I turn on the use glossy, you can see in the pre-process that the spheres are no longer black, and it is creating a secondary cache for the bounce seen from the reflective spheres. And now you can see the result is smoother. There's some blotches in the reflection because the pre-processing pass did not see it, and now the blotches are gone. And there's also a better shadow, but it took 4 seconds longer to pre-process. The wall here is still black. That was my mistake. It is because the color on the wall is blue and the reflective surface is red, so they're complementary. The same goes for subsurface scattering. If the setting is off, then subsurface scattering will not be included in the pre-processing, and it will probably be more blotchy in subsurface scattering if you don't use this option. So now we go in the cache option, and this is a little bit more complicated than it was previously. So we can turn on the cache. We can give it a name. Let's call it primary underscore. The cache type is currently set to frame. That means if I have an animation like the camera movement, it will create a new cache for each of the frames, and this is useful for when you have animating objects or lights or surfaces changing colors or light changing colors, etc., that you need to capture those in the cache. And then we have a scene-based cache. This means that the cache is going to be accumulated over the frames while baking, and it will not account for any animating objects or light colors, etc. So we'll leave that as a scene cache. The clear cache button empties out the file if you had a cache baked previously. The scene baking frame step is as before. At 1, it'll take 1 frame step through the animation, and if you set it to 4, it will skip to 4 frames like this and then bake those frames. Now what we have here are 2 different options to bake the cache. So we could do, I'm going to change this to a frame cache and choose bake frame. And you can see the new samples that are being added are red, and you can see how dense the samples are. So now we have this frame baked from this camera viewpoint. But since our cache type is frame and we move the frame, it looks blotchy because we don't actually have a cache here at this frame because the cache type is frame. So I can do a bake frame here manually if I want, and it will add that and it will automatically update VPR. But if you want, you can press the bake scene and it will automatically advance each frame and keep baking until the end. And then you will have this frame-based cache. The cache has a specific extension. It is called LightWave Irradiance Cache and Frame. It is a LWICF and the F stands for the frame. And then it will have an identification for which frame the cache was made for. So this is the cache for frame 0 and this is the cache for frame 1. Now if let's let it bake the scene, not entirely, but just to show how it works. Now it keeps advancing your animation and it keeps adding a new cache for each of the frames. After this one is done, I will abort. There we go. And now we go and look, and now we have more files, frame 0, frame 1, frame 2, frame 3, etc. And if you want to rebake a certain frame, such as frame 2, I can just delete frame 2 and press bake scene again. It will use those previous frames. You can see that it goes by pretty fast, but here is our missing frame. So it's going to rebake it, and then it's going to proceed to the next one, and it renders pretty fast because those caches were already there. And that is how the frame cache works. Now let's change it to the scene cache and bake a frame here. And you can see VPR update immediately after you have baked the cache. Now when we go take a look, now we have a new type of cache file extension. It's called LWICS and the S stands for a scene-based cache. It is only going to have a single file because it's going to use the same cache for all of the frames in the scene. And if I now press bake scene, it is going to see existing samples. And it's going to add to the cache. You can see in this corner here, because we've already seen it from a different point of view, it didn't add any samples. And now when the camera keeps moving around, we only added samples here. We're only adding samples here and here. And it is going to keep going through this animation and only add samples when it needs to. And everything else is recycled. Now I can abort this and we can take a look, and the file size has increased. Now it's 13 megabytes. If we do the bake scene again, you can see that it goes through these previously baked frames pretty fast because it can already, it knows that these samples already exist. And now we encountered something that we need to bake again. That is how the different cache types work. What I'm going to do now is going to add a new cache. I'm going to call it primary grid underscore. And now we're going to take a look at how the grid baking works. If you want to make your scene into a cache you can just look at and step through without baking it over and over again. And you can, if you want to go to locations you may not have, the camera might not have seen before, this is where the grid baker comes in. The grid resolution is the resolution of the probe that is being placed in the scene, and the grid spacing is the spacing between these probes that are being placed in the scene automatically for you. And the entire grid is a three-dimensional grid that is the bounds of your scene. So if you have a huge scene such as like a space scene, then I wouldn't recommend using grid baking. But grid baking is useful for when you want to, for example, bake an architectural scene that you can then quickly navigate using VPR. So I'm going to click on bake frame, and you can see it starts to bake the probes automatically for you. It shows processing grid, and it shows you how many locations there are and which location we are currently baking and how much time has elapsed so far while baking. Of course, since it is baking the entire scene, this can take a little while depending on your settings, and of course the settings are scene dependent. So like in this scene I would not want to use a really small grid spacing because it doesn't have a lot of small details that need to be captured. I'm going to abort this and load a previously baked grid cache. And now we can take a look at what a grid cache looks like. Because it has been baked previously, I can just look around and look around the scene without having to bake any of the locations. Hopefully that helps you understand the new irradiance cache. If you need more detail, a more detailed video, I'm happy to make one, but this is just a quick look at the new Global Illumination system in LightWave 2020.